Okay, so it seems that we're live. So hello everyone, I hope you're well. So today what we're going to be doing is I want to test out using, whoa, that's disgusting. Yeah, I want to test out today using the Q3 VM. Now, if you don't know what that is, well, Q3 stands for Quake 3, not for the quarter 3. It stands for Quake 3. And basically, in Quake 3, they have this VM that's running. Because basically Quake was a game that enabled mods by default. So for those that know Quake, you're probably either my age or older than me, or you have good taste and you're young. So yeah, so basically the QVM is just a VM that enables us to actually program in C and take our C code and lets it compile it to a QVM assembly code or whatever. So yeah, it works like in a couple of steps. So the cool thing about it is it's relatively known in general. So there's these beautiful graphics on how it actually works. So the basic logic is you have your virtual machine, and you have a virtual machine for the server, and you have a virtual machine for the client. Because how Quake would work is it's actually like Fortnite, but before Fortnite was popular. No, I'm kidding. So basically, Quake was a multiplayer game, and it was an arena shooter. Yeah, I don't know how to define that other than that. And for arena shooters, usually you would have a server and a client. And how ID Tech did it is that they had the game logic that would run on the server, and the bots would run apparently on the server. And then you had the renderer that would run locally on your game. So on the server, basically, you'd have only whatever is needed to be run for all players, so basically the bots. And then for the rendering, because you want to render on your machine, it would actually render with the renderer that they had. So there's a lot of explanations inside this if you want to read all about the Quake executable and how it works. I'm going to link it actually in a little file. So that's going to be the description of the video. So Q3 VM description. There we go. Okay. Now, in this description, what we can see is we can actually see how it actually works in the background. So usually when you're going to develop your game, you're actually going to use a language for programming. So what I usually use personally is I use C, and I pretty much love C, how it works. Is it the best language? Is it the end all be all language? Not necessarily, but right now it's pretty fine. And I kind of know it enough, and yeah, I want to use it basically. So C is cool. Now, what you have usually is you have your game. So let's say Quake3.exe. So you have your C code, and then you compile it with an editor or with a compiler usually, and then that will be compiled into some assembly. Well, not some binary. Sorry. So then you have your binary, and then it gets executed, etc. Now, the other way that Quake did it for Quake 3 actually is they had a virtual machine. So a virtual machine is something that can run your code. So it basically has bytecode. So bytecode is just basically operations that your application wants to execute, and then the VM takes the operations and transform them into the actual assembly that or binary that's used on that platform. Because on different platforms, let's say on different types of CPUs. So let's say you have x86 CPUs, so that's usually Intel CPUs or AMD CPUs. So those CPUs will have a specific instruction set, and some specific operations that it can do. So I'm not going to go into in depth on that. I can actually go in depth probably later on. So yeah, so the VM enables to like do that at runtime. So you kind of JIT compile, and the QVM has a JIT compiler, but it also has an interpreter. So the difference between an interpreter and the compiler, so the compiler is going to transform the different operations from the source code to actual binary, so binary operations that the CPU can run, while the interpreter, what it actually does is it takes your code, your C code, and then it just executes it in the executable. So it won't necessarily transform that into binary code that gets executed. It executes the operations directly. So usually interpreters are slower than actual JITted code, because what happens when you JIT the code is it's like you would have a compiler that compiles the code. So the operations and how it will run is going to be native as if it would be statically compiled from the beginning. So with the interpreter, since it kind of interprets the code, it's a little bit slower, but the value of that is, well, just look at Python. It's an interpreted language, and it's pretty much used everywhere. So you can still have an interpreted language and it still be valuable, even if it's slower than the statically compiled or the JIT compiled code that you would develop. So why am I talking about all those big things? Why do I want to work with this? So basically, I'm kind of researching a way to have hot reloading. So one of the ways that I have hot reloading right now is with Knob. So Knob is the build tool that I use. So we have a kind of hot reloading system, but right now it's kind of clunky because we need to separate, like we need to generate. So if I open like another project, so that's one example, but I guess this used it. Because this doesn't work right now, but yeah. Yeah, so this has hot reloading. So basically for the hot reloading part, what I kind of need is a kind of DLL thing, and then I need to expose some code with the DLL, and then you need to make some like plug.c thing. So yeah, so we have the hot reload.h, which reloads the libplug, and then we have the function that actually reloads it. So this basically calls DL open, and then it gets all the functions, and then it enables us to hot reload our code. So we basically compile to a shared object or dynamic library that we would say, and then the application can still run, but then we compile that to a DLL, and then as soon as we change the DLL, we reload it inside our application. So this mostly works, but there's a lot of finicky stuff that we need to do. So like with the libplug stuff, and then, because I know there's like, where is it? So hot reload.h, yeah, and yeah, plug.h. So we have like plug.h somewhere, and then we need to define all of these things. It's school things that weren't actually made by me. It's actually something that's been made by TS Oding. But yeah, it's a cool system that uses X macros and stuff, and it's really interesting in a way that you can get hot reloading in C relatively easily. But I've been researching on other ways of doing it. So another way of doing it is actually using a very dangerous language. So that very dangerous language is actually C++. So I have a project that I've been making that's called C flat. That's a C flat test. Basically, it's just like an example application that I tried to use that C flat thing in. So the logic is you implement the logic for your game in C++, and then you have like a script manager or whatever. And what it does is what I do right now is if the file has changed, I just reload the file. And then you can do that. So we load the scripts here. We reload the environment. Where do I call the reload environment thing? Yeah, here. So in the update, what happens is we kind of fetch, like, should we reload the environment? And then we fetch the environment, and then we call all the functions. So that mostly works also. And there's a cool bit with that one is it's also an interpreted C++. It's a C++ interpreter, basically, which, yeah, that's cool, right? It's interesting. I can actually show you C flat. C flat. Wow. Yeah, that's not gonna work. GitHub. So yeah, that project is pretty cool. So you have a version that's interpreted when you're developing, but then when you want to ship your game, you're actually going to take your code, and since it's valid C++ 11, you can just compile that to a dynamic library, or just compile that to object files, and then you just have access to the code. Now, I like C++. I think I like C flat. How it works, like the iteration time is really fast. There's a little bit less finicky stuff. There are still some finicky stuff. So, because like one of the things is every time I want to start a project, I don't want to have to like always have to set up multiple stuff just to have hot reloading all the time. So I want to have something that's relatively simple. I drag and drop like C and .h files or C and C++ files, and then I can just compile that in, just start writing my scripts. There I go, right? But right now, like the way C flat works, you have to expose most of the functions in different ways, and then you need to expose the structs, which it's all fine and dandy, but at the same time, it's kind of annoying. So I'd like something that's, I don't know, like easier to handle, easier to like have and whatever. I forgot my water, so I'm gonna need to drink at some point. So I'm probably gonna get up and get my stuff. But yeah, so it's really interesting. And then like even in there, if you want to look for like real C++ subset and stuff like that, there are other examples that people have used. Seriously though, those look heavy and like some like this is cool, right? But yeah, the other ones are all interesting projects, but they're like the pain that you need to endure to have access to it before starting implementing your project is annoying. I really want something that's like you select it, drag and drop it, and it's done. And then you just need to start writing your code. You got hot reloading, everything is fine. Now, when you want to have something like that, you still need to do some tests. So that's what we're going to do today. So I'm going to link C flat also in the description because I think it's cool. It's a cool project. So hot reload. Whoa, I can't write, buds. hot reload C++ with a C++ interpreter. There we have our interpreter. So yeah, so C flat. Blah blah blah. I don't know how it works in like the video description stuff, but yeah, that's how it works here. C flat. Okay. I closed that because I'm stupid. Yeah. Okay. So yeah, that's the C flat way of doing stuff, and it's really interesting and it works well. So the finicky stuff that I was talking about is this. So like for each function that you're exposing, you need to define and register that function. And you need to define and register the enum. You need to define and register the structs. Those are all fine, right? It's just, it's more code all the time. I could make a generator for it. And that's one of the ideas that I had, like just parse a C or C++ file and then make a generator. But then like parsing C++ isn't easy. It's quite demanding. So do I really want to do that? I'm not sure. Like parsing C, like using a LLVM, libclang, whatever, to like generate these stuff, that like it could be possible. But right now it's not something that I want to do. And so I want to like investigate what are all the other options. Because like we tested the TS-ODing one, and then we tested this one, and both are interesting. Let's see if we can use something better. Now, is the Q3 VM necessarily the better contender? That's the good thing that we need to ask. So, what it does right now, because this Quake 3, like I said, is an old game, basically. So, am I not looking at the chat and people are in the chat? No, okay. So I'm just going to leave the chat open. So yeah, when we have like our... So how does it work? How does it work for the Quake 3 VM? So basically, you have your game executable. Now your game executable, from what I can understand, it's going to, well, we're going to have a look at how it actually works, but you're going to have like two other executables. So your game, and then you're going to have like a compiler, so the little C compiler that you can see here. And you're also going to have the Q3 assembler. Okay, those seems like other applications. How are we going to work with this? How are we going to work? So like the advantage of TS-ODing's hot reload system is you just need a compiler, you just need your C code, you can just directly compile it to a DLL and you're done. That's one of the advantages. The disadvantages, a disadvantage, yeah, is you need to implement everything in like a plug update, plug in it, and then it's gonna hot reload. When it hot reloads, you're gonna call init, and then yeah. So it mostly works for most applications. It mostly works in general. The thing that I didn't like is the setup of it. So like you have to set up a couple of stuff. It's not that annoying. As soon as it's set up, it's kind of fine. C flat had faster iteration time, from what I can gather. Because what C flat did is, and like it was seamless in a way. So like if you wanted to compile the binary version, it was more seamless with C flat than it was with the hot reload thing, even though it's relatively similar, but it's just different. So yeah, and I think for the hot reload version of TS-ODing, it was really the setup at the beginning of like drag and dropping stuff and like having the hot reload, setting up the hot reload, it's always kind of tedious. So this could be better, but the issue that this has, so one of the advantages that C-flat had is when it hot reloads, the only thing that it needs to do is it won't actually unload a DLL and then reload a DLL. It's going to take the C++ code, so we can actually detect like which file changed, and then just load that file in the environment. So we're just reloading that file in the environment. Cool. But in theory, will that work in that consideration? Because like this creates, we need to create some, it compiles the data to an object file. And then this object file is taken by the Q3 ASM executable, and then it generates a .qvm. So in theory, we can like hot reload similarly to how it was done with our environment. But like we're gonna need to test the things out. So in one KVM file, it also transforms everything from text to binary for speed in case. Yeah, also recognize which methods our system calls. No. So the disadvantage of this this way of functioning is actually that it uses different executables right now, right? Because I started looking into it, and what I want to actually do is I want to have the same workflow that I had in the other with C-flat, basically. And what we're going to do is we're going to take the little C compiler and the QASM executable, and we're actually going to make it go in our engine executable. Okay. And then what's going to happen is, relative to if a file has changed, we're going to recompile the QVM file. Now, I need to do tests, because one of the things that I was wondering is, can I have multiple QVMs? Probably, because if we look at the logic here, it has multiple virtual machines. So you have a virtual machine for the UI, you have a virtual machine for the C game, and then you have a virtual machine for the game on the server. So inside the same executable, you have basically the same two different virtual machines. So there are a couple ways that we could work. So I think that we need, for each .kvm file, we may need to be able to actually compile a KVM file for each file, which that would be a waste, but that would enable us to have as much hot reloading that we want per file. The other thing that we could do is we could bundle things together, but again, that might also be an issue. The other issue that we have is the little C compiler. That's an old compiler. Like really old compiler. So like it compiles C89. C89, I wasn't even born in in 89. So C89 is old because I'm already old anyways. So yeah, it's going to have some limitation. I need to look like at the little C compiler. Little C compiler C version. Because it's LCC, yeah. So the current version of is 4.2, but much of the book still applies into this version. And yeah, whatever. I can actually, I think it's C89. It's kind of fun that it doesn't say features. It says C23, C11. But does it really support? Like, maybe it supports C99. Like, in the best of both worlds, it would support C89. C99, sorry. C99. Okay, so this version offers C11 and C17. Pele C. So then you have this one. Because I know that this source, the LCC version, so we have LCC here. Version 4.1. Yeah. So let's go. It says in doc 4.html. So doc 4.html. Let's have a look at the raw. Is the latest release. Blah, blah, blah. Supported only 3 sizes of integers, 2 sizes of floats, and insisted that pointers fit in unsigned integers. These assumptions simplified the compiler and were suitable for 32-bit architectures, but on 64-bit architectures, it's natural to have 4 sizes of integers and past 3 sizes of floats, and on 16, whatever. Removes all these restrictions. It supports any number of sizes for any integers and floats, and the size of pointers need not be related to the size of any of the integer types. Cool. The major changes in the code generation interfaces are okay. The DAG operators is written in NCC and uses the standard IO library and other standard C functions. Yeah. Like, what's your C version? Let's write like C99. No, it doesn't seem like C89. Because, like, there's a couple of things. Like, I probably only need C99. Yeah, so we're not going to read this, but because we can see in the issues that one of the thing is it's the C in R, whatever. Yeah, so right now it seems like it's C89. So we could look eventually, because there are other C compilers that we could use. Like, for example, oh yeah. So there's another C compiler that we could use, because right now it emits like assembly directly, and like I know that this compiler has some good generation. So we're gonna start by integrating it, or start by using the VM, the Quake VM. But eventually, I would probably use another compiler with, let's say, C11, which is C11 is pretty good, so it could be a good contender. And then we could generate the object files that would be consumed by Q3 ASM. So why would I do that? Well, the biggest reason is actually that if the Q3 VM enables me to do exactly what I want, and I just need to like make a code generator, well, first, making a code generator is interesting. Second, if it does exactly what I want, I'm going to use it. So yeah, so the first things that we're going to use to do is actually make it so that the Q3 ASM can actually is integrated into the environment. Also, we're going to need for the little C compiler to also be integrated in the environment. So what do I mean? So basically, right now they are independent executables. So I want to make them not independent executables and make it integrated in the engine. So whenever a file changes, we just call functions that actually do the work, and then we reload the environment, basically. So that's fine and dandy, but we're going to need to start somehow. So I already started a little semi-project. So basically what I have right now is I have a hello world. Now, if we run F5, our little hello world actually works, right? Now, from what I can understand, okay, in the in Q3, not in Q3, so in Q3 VM, yeah. The only thing that we need is VM.c and VM.h. So I'm going to copy, well, not copy, but I'm going to copy the path. Let's call it relative path. And then in our compilation, right here, we have files that we want to build. Now, for now, we're just going to directly add the files. So let's call like VM Q3 VM files. End. Right. And then we're also going to add VM.c. So that basically adds the file for compilation. In the includes. Yeah, so the includes are not the includes that we actually need. So right now, let's just add them directly. And we're also going to need dot. So let's add these guys. Okay. Eventually, we're going to add probably raylib and stuff like that. But first off, we need to actually be able to run the things. So there we go. So then we have the dot source. And then we also need this. This is probably, yeah. Yeah. So dot slash, there we go. So now, we're going to compile the VM. Now, how it works, like I said, is if we read the readme, where are you? The readme. Oh yeah, so I'm going to need LCC. Let's have it in preview mode. Yeah, preview mode. Okay. So a single file, embeddable interpreter, virtual machine for compile bytecode, blah, blah, blah. On good old C language input, a complete C compiler to generate QVM files is included. LCC, the interpreter, is based on the Quake 3 Arena virtual machine, hence the name Q3VM. The interpreter is not tied to Quake 3 Arena and can be used for any kind of project. For example, code that needs to run in a sandbox. In the sandbox, man. Okay. So this is an example of like copying and like compiling and stuff like that. For installation, files can be dropped into an existing C project and compiled along with it. Implement the 4 callback functions in your project: alloc, free, error, and system calls. So there is an example of that. Example. So this is the the example in question. And these are the system calls. Kind of weird. So how does the makefile work? Bruv. So D Q3VM -S WF target bytecode WFG whatever. Okay. Then you build. Yeah, so first step first. Let's compile because right now we don't have any binaries. So it's sad. It's so sad. So sad. Let's just call make. So that's gonna compile the assembler. And it's gonna go Q3ASM and LCC. Q3CPP. What is Q3CPP? I'm kind of curious. Help. 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 Yo, bro. Yo, bro, like, no. Can I just do like a dash H? Line 1. We won't be using Q3CPP. Does this one have a help? Yeah, this one has a help. Whatever. Verbose compilation report. Produce a QVM file compatible with Q3. Buckets. Set symbol hash table for 2 buckets. Interesting. List file. Read options and list of files to assemble from list file.q3asm. Write assemble output to a file output.qvm. So yeah. Eventually what I want to do is actually take the assembler, take the bytecode, well, make a bytecode generator, and then just have it in one executable. So right now we're going to use LCC, and then here we have all the beautiful arguments of LCC. The WPFAL arg, pass arg to the preprocessor, compiler, assembler, or linker. So what does F is probably Fambler? Fassembler? I don't know. Maybe Fassembler. Anyways. Yeah. So we do have our LCC and we have our Q3ASM. Cool. So cool. So what we need to do is we need to have like this command. So we pass it a main.c and probably has the command somewhere. The interpreter, a bytecode binary. To run, we just have the executable. So this is pointer to bytecode buffer. Whatever. Anyways, yeah, we just made it. We just compiled it. So this. So we're gonna need this. So since we want to test things out, I'm just gonna need a define for stuff. So define LCC. Let's do like copy relative path and then libraries QVM LCC. There we go. Because we're gonna want to run this eventually. Then define C flags. So bytecode DFF. So we're gonna need the C file afterwards. Okay. And he also did some like, okay, and we also need Q3SM bytecode. Yeah, I'll put a QVM file. Cool. Because we need this to actually work. Let's call it assembler. Define assembler. Whoa. Q3ASM. And there we go. So now we need to do -f bytecode. Yeah, let's have a look at his GIF again. So he has the demo. He compiles the demo. So then F demo. Okay. So demo is the folder, or is it the file? Yeah, it seems like it's the folder. No, but he is in the folder. So it's just the name that we're giving to the QVM file. Okay. Let's do like define. Whatever. So the cool thing with this guy is that I can run any commands. I can run any commands. So then, yeah, we're gonna do that. So we're gonna need to run LCC on the code. So first things first, cmd dot count is equal to 0. That's basically how we reset commands. Then we're gonna need to do LCC. I'm gonna do C flags. What's your issue, bro? You're not the issue, actually. So C flags. What did I do wrong? C flags. Gosh, that was terrible. So let's do it like that. We will need commas in between, and then you be like that, and then you be like that. So yeah, we can do it like that for now. We have C flags. Then we need to pass our, we need to say like .o. And then what we could do is we have the build folder. Build. Yeah. So this. And then let's call it like main.asm. And then we're going to do main.c. Because we actually need like a little example, right? First. Okay. So our little example. So that's going to compile. So we're going to run the command. And then we need to say we will need new commands. like, I don't know how exactly Q3ESM works, so we're probably going to need to change the command, but let's do it like that for now. So we know that we're going to need -F. We're going to need assembler, and I don't know if it's going to call it like main.qvm. So we're going to test the command, but if it fails, it fails. If it doesn't, it doesn't. What is your issue? What is your issue? Missing a closing quote. Where? I hate when it does that. So let's have a look. Like, buy more RAM, lol. Is it because of the dash here? Oh. It's because of the assembler or whatever? Yeah. Dumb. That was dumb. Okay. So, don't you love it when it's dumb? Don't you love it when it's dumb? Because when it's dumb, it's just easy to fix. So in theory, let's go in, like, one of the things that I don't like right now is I need a scripts folder. Now, scripts, and then let's call it like main.c, and like this is going to be scripts / main.c, and then I mean, we probably need to rename it like gmain, something like that. Let's call it gmain. Gmain. Germain. And I think I need the assembling stuff, like the assembler. Jesus calls. Let's copy that. So eventually, I think I'm just going to generate those. But yeah, for now, let's just do it like that. No. What we do need, what do we do need, what do we do, what do we do? This is weird. Okay, it built the GASM stuff. Yeah, okay. Because it, like, just builds the examples and stuff. VM. Like, I know there's an example, so yeah, we need those. So we're gonna like copy this whole code. What did I do? What did I do? Did I kill it? Kill it with fire. Okay. Why is there an error somewhere? Oh, because of the VM thing. So LCC can't find scripts.main. That's an interesting one. Yeah. I think I need a dot before. So I'm going to add the dot. The dot slash. Abort. You can't find that. Okay. So, let's do that. Then this we're going to change it to render.count is equal to 0 because we love it. We gotta love it. What? Why are you not doing that? Okay, so let's go. The cool thing about having a build script that's in C is we can actually debug what's happening. What's happening? So then we have to render items. Yeah, bruv. Render count. Really? Let's just change it. I thought we could just like say, yo, you don't care. Maybe I could put like 0 at the beginning. So like items 0, and then you like do this. Will that change anything? So the command is that. Then we're going to render the command. So what do we have in the items? Was what? Oh, because I'm stupid. That's why. Gotta love showing that you're stupid. Gotta love it. What do we have? So we have the executable. Yeah, so we have this. Oh. Okay. Let's do a memset instead. Because this is just stupid. This, and then we're going to say 0, and then we're going to say render dot count. Because, like, really? Okay. Okay. So, it finds dash build. Look at this. Oh no, it's scripts main. But it still doesn't find it. Yet it finds. Oh, does LCC? I'm gonna do a test. I'm gonna do a test. Let's go in build. No. No. Bin. There. So like, if I just like copy and then I just paste, does this work? Blah, 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 blah. Like, dude, where are you searching? Have a look at the GIF again. You see these in the demo. He changes the text. He calls LCC directly in there. So maybe LCC can't resolve paths. So let's just delete this bonkers. Let's delete this bonkers stuff. So copy path. Then we're gonna go in here. And we're just gonna put the absolute paths. This is gonna be disgusting, but if this works, we're gonna use it. So it can't find it. What? So let's do just this command. Okay. Am I being stupid? Yes, I am. So it's not called main. It's called gmain because I'm stupid. So let's call it gmain because I'm not stupid anymore, basically. Cool. It can't find. Really? Oh yeah, I'm being stupid. This is the host application. So this should go here? Yeah, let's. Oh no. Oh no. The copy pasta. The horror. So what do they have in gmain? So that's my gmain. So what do they have in their gmain? Blah blah blah. So this, I guess. And then you need the bglib for printf. Is there printf in there? Printf. There's vs printf, but there's not printf. There's only vf printf, so I probably don't need that. So we're just going to need the vmain function. So this is the only way to control blah blah blah. So let's do, and then print. Oh, it uses vs printf to actually implement the printf. So let's copy. Paste, and then we're gonna copy paste. Let's do that. Copy, paste. Because in theory, I could just probably pass trap printf. It's kind of interesting that you don't need. Let's not call fib. Let's just do lol. and then 69. Okay. Oh, wait. I do have the I here, so 69. Cool. So, let's recompile. I actually don't need this anymore. No new line. And whoa, are you really that Nazi? You seg faulted. Let's have a look at how he builds this. Does he? Maybe I need DQ. Let's add that. Okay. It's still seg faulted. By segmentation faults. Did I do that? Did I do the... bin Linux? Okay. I mean, we have this, right? So we can probably just run this file. I would have liked to be able to like compile it, but it's kind of annoying. -S. Do I do the -S? -S WF target bytecode WFG. We also have he also has biglib.asm, right? What is C sources? Okay, what is sources? I tell you, for each dir, source subdir, wildcard.c. Okay, so bruv, this is some next level hackery. Like, I kind of understand what it wants to do, but the way that it defines it, it's disgusting. Anyways, I have a QVM file. So let's copy this for now. Let's paste it in here. Because this doesn't work. This does not work. So for now, we're just going to leave it as is, I guess. I really find it weird that it seg faults for a reason. Like, the difference, like if I copy paste So that's mine, right? Okay, wait. Let's say I copy paste all of this, right? Does it still segfault? Is it because it's missing 2 new lines? Wow. Is it that frail? No. So like it really just segfaults. So it's not even the fib that's the issue. Maybe it's the .build main. Let's call it like main.asm or whatever. Because maybe it can't like... Maybe it can't handle life as we know it. So let's call it just like... main.asm. But it still like generates it, which is kind of weird. And then it generated it here also. Pooh. Pooh. Wow. So like it generated the file. So like it's not the .build thing that fails. It's the fact that it's a file. Wow. Looks frail. Don't quite like that. Like when it runs it with the makefile, like if I go have a look at the makefile, does it segfault on the makefile? And can you pass it like multiple files? Like if I say like, we're gonna do a test, right? Oh, whoa. We're gonna do a test. So we're gonna pass like bglib.c, right? That's it. bglib .c, right? Because I'm a dumbass. Okay. So it built both of those. But it's still segfaults. Okay. Let's have some fun. Like if I just use this command and like I do build asm gmain, right? Let's say I just copy this and then just add this here. What is that? So let's say I delete this, okay? So right now in my build folder, I have nothing, okay? It worked. It does not say segfault. Why does it not say segfault? Interesting. So let's see the execution. So it runs it. Command count. Oh, it tries to do this. And then it's sex faults. Please tell me which command sex faults. Oh, I need water. I'm kind of curious now. Like, why does it seg fault? Okay, and then command render. Actually, we want to copy both of those. So let's just run like Q3 ASM. Maybe it tells us like the F command is dodgy. It's dodgy. Let's do like the verbose version. Like if we do this, if we do this, if we do that. Maybe we need to pass both options. V. V, 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 V. So basically, what it's telling me, -v.q3sm, no such file or directory. Okay. Okay. So maybe, just maybe, the issue is, like, it's not being more verbose. Anyways, so maybe, just maybe, wow. Life is pain. I'll get water, I'll be back. Okay. So the thing that's going on is for one file, you need two files. So we're probably going to simplify the code. We don't actually need a complex printf. We just need trap printf texts, because text is just a car pointer. So let's just do, let's say bye-bye to those. And then let's say bye to this. Also, I like Egyptian style. We'll leave it like that for now. We'll say bye-bye to this, and then needs to end with this apparently. Hello. Hello. No, let's do like hello. Hello pimps, whatever. I'm gonna need to destroy the ASM files. I'm gonna eat a little bit also, sorry. Hello pimps. We'll just pass it like that. It's gonna be a trap. Okay. Cool. Cool. What is this? So now the issue that it has, output file name. Okay, so maybe we could like specify an output file. What is it? Oh, okay, yeah. So that's the interesting part. What does he do with the assembler? Because like I feel like he's specifying G syscall or whatever. G. Okay. What is the Q3 ASM? Q3 ASM. Yeah, so here we look at link F bytecode. So is it like detecting syscalls ASM directly? So like if I put that here, will that just work? Okay. Let's have a look. It's time to grep. It's time to grep. Interesting. So it did not create the file. It's trying to find export.asm. Okay. Is there something in that build folder? Bin Linux. There's nothing here that would, like, in the build. Yeah, there's nothing here also. So how does it like, why do you have the Q3 SM and then what I think I get it. This is a definition file. Okay. So O is going to be bytecode, build, gmain, gsyscalls. So then yeah. So let's copy this. I want to understand how this works, because like, wow. Move there. Do I really want to move it there though? Okay, so let's paste it. Let's do like O bytecode. I don't like, what is the Q3 ASM file like? Let's go online and let's have a look at like Q3 ASM. Yeah. Yeah. Notes. Sure. Yeah, what is that? Can you give me an example of what it does? What it does? So based on, and then this generates and build the ASM file. Okay, so I can just do like F bytecode, and then based on the define, it's gonna go getting the values. But I'd like to pass the commands. I like passing the commands. Let's just do like because like maybe we could just do like bytecode, but it really annoys me. So like bytecode, and then out deployment / bytecode. Let's do it like that. Okay. And then because that's going to be, yeah, we're going to need that. It's going to have main. Yeah. So that should work. Oh, I called it bytecode.qvm, but it's not my job to do it. Error opening gsyscalls.asm. Okay, so if I do, so this makes sense, right? Because I think it's 9 symbols defined, stats for hash table, buckets, 9 nodes, longest chain, empty chain, no. Code segment, data segment, lit. There's a lit segment. Probably literals. BSS segment, to deployment bytecode, KVM, blah, blah, blah. What? I'm curious. So, what's the F for? Oh, it's the list thing, right? So if I do like Q3 ASM, and then I go boop, the list file, read options, and list of files to assemble from listfile.q3sm. Okay. Makes sense, right? Okay, so I get how it works now. So is there another way? Another way? Is there another way? Probably. So like this works, right? So let's leave it like that. I like when things work. Let's do like the .o, because I like configuring things directly in my build file. It kind of makes sense to do it. Then we're gonna go and /deployment. Let's call it bytedance.qvm. And then how it seems to assemble stuff, it just says like build /main, right? And then it says like scripts gsyscalls. Yeah, like that. So like, is it going to be able to assemble? It did. Okay. So that's the way to do it. Can you put this before? Because it's kind of like weird. Can I put this before, and then I'm just gonna delete those, and then byte. So no. But if we put them afterwards, bytecode, that will work. Yeah, that will work. Okay. We are able to compile a C file and then assemble it to a KVM file, a QVM file. Me happy. So we know that we can build stuff. Now, can we run it? That's the question. I'd like it if we could call them QASM, because this isn't really ASM, but yeah, whatever. Okay. Now, we know that it's going to say hello pimps, but now we need to like handle our main. That's the trap printf, that's the error, that's the memset, and the mem valid or whatever. Then we have the load image, com malloc, com free, com error, and let's load it from like that's slosh. Let's. Oh. Why do we need? One of the things that I hate is like quick fix. Yes. Add it. Now stop whining. Like, it clearly knows what it needs to do. I don't know why it asks me. Like, you know, it's an include. Include it. Okay. So we're not going to need... Yeah, we're not going to need that. We're going to use... Yeah, we can like just do that. And then... Yeah. Okay. Oh, what? Yeah, because I'm dumb, right? So bytecode .qvm. Because of course it would like be null. Okay. Ooh. Why did it need the file path? Yeah, we're just gonna do that, I guess. Whoa. Whoa, what's going on? Something's off. Let's reload the editor because reasons. Okay. So file path. Why did it compile though? Like let's do that. Basically it's just that, right? So file path. Let's not change the rest of the logic. So yeah. La la la. Who? Illegal instruction. Interesting. Prepare interpreter. Byte PC. So like if we go here, what do we have? Okay. So what's... Okay, so let's go inside of this little bad boy. Bad boy. Okay. Bad boy. So open file size, malloc, read size, image, system calls. Okay. I mean, it's kind of annoying right now, but because it kind of breaks for whatever reason. Okay. VM is null. Well, VM should be null, right? Huh. Okay. Do I do this, maybe? If not, system calls, sure. Okay, so it mem sets it to 0. Bytecode QVM. Then you load that. Bytecode. Okay. Loading VM file. Little long. Okay. So it has a good header. Round up, next power of 2, so all data operations can be mask protected. Okay, so this is gonna allocate 0 filled space for initialized. Okay. So come malloc. Size T. So that's the data section. Make sure that section is always initialized with zeros. BSS would be enough. Okay. So that mem copies a little long. So the header seems fine. The system calls. Well, yeah, compiled. Okay. So my guess, since it's calling malloc multiple times in a little short time, how much do you guess that it actually just borks itself because of the malloc? So now, since I'm going to be going slower, yeah, that's it. I think that's going to be it. Oh no, it did fail. Huh. Interesting. Let's just test something out. Car. I mean, it's just like, it's stupid, but it's what I'm going to be doing. Sometimes when all else fails, you have to fail in another way. Blah blah. Hello. Hello. Whoa. To the wall. Down these things crawl. Down these people crawl. Down, ski, 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 skis, down, ski, skis, down. So I thought this would work. Doesn't seem to work. Well, so we have like QVMs here. So like, yeah, this guy. So like, let's just stop for now. Let's do like, what do you ask? QVM, bytecode QVM. Yeah, so let's do like this, and then let's just give him like this. And yeah, so it kind of fails on that, which is odd. So let's go and get the actual good version. So in the example, we have the bytecode here. Let's just like copy that, copy, and then paste, and then I'm gonna delete that. Then let's just like comment. Let's comment out these guys for now, because I just want to test, like, will this do the same? Yeah, it does. Okay. Interesting. Because, like, that's his code, right? Q3 ASM. Unknown token D. Unknown token D. What? Okay. Copy path, CD. Let's CD there. Okay. No. No, that's not what I wanted. What command did I run before? Oh, because I'm stupid, I guess? Yeah, I'm stupid. QVM. And then let's run this. And then, because what we not want to see is, can we actually just run it at all? Because it seems hello world doesn't segfault. But, okay. Oh, wow. Do you actually need this in the deployment? Because like if I run, this is not mine, right? So if I run QVM and I pass the QVM bytecode here. No, not that. That. Now it's not going to work. It does work. Why does it not work? Okay, so now if I pass it this, will it work? Okay, so it does work. So the Q3VM file works. Okay, interesting. So then why does it fail in my case? Why? Because like the QVM can run this. What? Oh, okay, wait. So if I take QVM, okay, and I go and get this one. It works. So the QVM file is fine. Okay. What am I doing wrong? Isn't that exactly the code that I use? Huh. How does he build the QVM thing? GC sections. What does that mean? What? You need to use C89. So my guess is really that when we're compiling, there's something else in there, but the fact that we're using like weird if it's uname, okay, so remove dead code at link time. It's a special case for what? What is GC sections? It's interesting. So we're adding this. Seems like stupidity to me, but there's probably a good reason. So let's follow. Because, like, you're supposed to be able to make your own, no issues. But like, yeah, there's issues, dude. When he's building the examples, blah, blah, blah. So yeah, we have this. Yeah. That's fine. So it's probably the hacks with computed go-tos that are kind of the issue here. So let's add to our C flags. So let's do I don't like that he's using I don't like that he's using like what a heap of like flags that kind of weird. So yeah, let's do those commands. Well, I say commands, but they're actually not commands. Brother. Brethren. Wow. Brethren. Brethren. Because there's probably an issue somewhere around here regarding flags. I don't like having flags that I don't know what they do, but for now we just want to have it actually working. And if the O2 is actually making it work, that's cancer. That's pure cancer. Whatever. Darwin, dude. Okay, will that fix... Abort! Good one. So I am using Clang, actually. I'm not using GCC, so... that could maybe explain some stuff. Let's leave it like that. Sure. We still got an illegal instruction. So sad. Okay, let's use GCC. Let's use GCC. So where's my compiler? Where's my compiler? So let's use GCC, I think. Yeah. Actually works. What? I don't like that. Not at all. I mean, at the end of the day, I could actually use something else. Because basically, I'm using Cosmos CC for some of my work. Cosmos CC is actually GCC. So as long as it works with Cosmos CC, it should work on most platforms. So like, yeah. So if config compiler is compiler GCC. We should add those. But then if I add zig, it won't work. And then if I add GCC, it just runs. Okay. So, like, this is an easy fix. I just don't like it. I don't like it. Not at all. Okay, so have fun. Let's have fun anyways, right? That's the goal. Let's have some fun. So we can run the KVM code. Let's run our own code. We just want to say hello. For that, I'm going to need to uncomment our atrocity, which is going to create hello. Hello. So let's change this code. Hello, pimps. I got something better. Hello, wimps. There we go. So we got hello, wimps. Cool. Interesting. So this works. I like that it works. I do. The stressful part is the fact because, like, how I understand it right now, it does the hello wimps. What happens if we have a while loop? That's the... So, like, while... Let's do that. So it's never gonna give back the control. But the VM main is something that we can pass to everyone. Another one. Can we define enums in C89? Let's test it out. So we can use, like, because from what I understand, the command is the first value. But, like, what do we do with the 12 parameters? That's the question I ask myself every morning. So yeah, because, like, what we could do is we could have a update command. We could have an initialize command. We could have a render command. So that way, we could write our code in a certain specific way and then just do a VM call with a different like command based on it. And an enum would be a good solution in that case. I don't know how this works. So for now, I'm gonna... Yeah, so it can include other people's code, right? So literally what we could do is we could define in the scripts or somewhere else like in source, right? We could define command.h. And then I don't know if pragma once is supported. That's a good question. Anyways, let's maybe... Does he have like if and defs? He does use if and defs, I think. So if he uses if and def, yes. I don't like that. LCC hashtag pragma. Little C compiler. Little C compiler. So I'd like to know, like, if the little C compiler actually supports it. So let's write it. Let's make a test at some point. Please to do test that pragma once is actually supported. So now we're gonna make an enum. So let's call it com init. Com init, boy. So com update and com. Hey Mickey, how are you? So com shutdown. So what do we do with this? So commands. Let's call it commands for whatever reason. Okay. So in our VM, we are going to include /source/ command.h. Now let's see if it actually compiles. Yeah, so it does compile. Let's bring commands in here. Let's call it commands because it's kind of annoying. Do you hear me, Mickey, or did you already leave? These are commands. Okay. Commands. Ahoy. Ahoy, matey. maybe you're working on something, right? So you're listening on the side probably or something like that. So switch, and let's do command, and then let's say like com init case, com init. Oh, okay, interesting. So you do you like working on Quake the game while the mods and stuff like that? On my side right now, what I'm doing is I'm actually using the Quake VM. So I'm not fiddling with Quake per se, but I'm fiddling with the VM, the virtual machine. Updating logic. And then case com shut down. So we're gonna do trap shutting down. And let's assert if we trap error. I think it's trap error. Trap error. Error unreachable. Starting up. I'm going to need to have a way to detect that we're starting / shutting down. VM main. So then we have the commands. We don't have the commands. So include commands.h. Yeah, exactly. Like looking at all the ID Tech code bases are really interesting to look at, to see like what you could do as a programmer. Com init. Then we could have a while. This is going to be a infinite loop for the funsies. Then I'm probably going to add like some new logic in there. Com update. And then shift tab. Shut down. So right now, let's do like a for loop. Because I just want to test, I just don't want to loop ad nauseum. I is smaller than 10. Because Ben 10, why not? Here we go. So we're going to call the update. Then I'm going to do that. So unreachable gets called. Oh, because we don't break. Ha. Ha 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 ha. So at least the code runs exactly like I would expect it to run. Break. Why is the command line so short? What happened to my command line? It's become a little thing. And then is that it's not bigger. It stays small. Wow. Me so sad. Okay, so starting up, updating logic, shutting down. Okay. So I think that we can start actually working on this because I kind of know how the engine works right now. So the next step will actually be to add Raylib support, like I said in the beginning. Well, not the the beginning, but like in the title of the video / stream. Because right now we have a build that works. We can actually run code in a specific way, and the next step is to run other people's code and actually do fun stuff like detecting input, handling input. So Mickey, just wondering, so what other development work do you actually do? So we're gonna need to have Raylib. So how do we get Raylib? Well, pretty easy. We're going to add it as a submodule, like I did with my other projects, and then we're going to add the build with it. Now, so we're going to go look at the game. So in there, we actually have a, wow, everything is really small in this one. It's kind of weird. Anyways. So we have Raylib. And in here, we have a marvelous build script that we can probably use today to enable us to do this stuff. I don't know why. Oh yeah, if not defined, define, yeah, because it's a submodule. And then in here, we build Raylib. We get the parent config. Okay. I should probably just make it a little simple submodule, but right now I'm gonna complexify my work and just build it to, okay, because it receives the config, the parent config. Aha. I'm gonna have to look like how I did it, but yeah. So we're gonna copy some pasta and let's add Raylib in here. So a Raylib is going to be github.com/rayson 5, I think, and then it's Raylib. Okay. So usually I think what I do is I just get I add it as a submodule, and then I get the actual release. Yeah, that number. So let's go. So let's get submodule add, and we're gonna add raylib in here. I should have added like depth 1. Did it finish adding it? No, right? So I can delete it. Not that one, that one. So git submodule add this, and I think I can just do like submodule. I want to search and find like, can we add the depth of a submodule? So get depth submodule get depth. Yeah, can we do the dash dash depth? In fact, no. So I can just do depth 1. I'm gonna try it. Maybe it's gonna get in the way. I will need to force you to do what I want, apparently. For whatever reason, like, you are in a branch yet to be born. Cool. So is there a submodule file somewhere? Git rm. Let's just rm libraries raylib. What do you mean? Libraries raylib. It exists. -f /. Let's do it like that. Really? So it does not exist. We're gonna need to go have a look at the Git files. Modules. There are no modules. Yeah. Heads, tails, branches. Yeah, there are no modules. So like, why do you... So I'm just gonna add it like this for whatever reason. And then you are on a branch yet to be born. I'm on a dead branch, bro. Wow. Git can really shoot itself in the foot. A Git for is found locally with remotes. Origin, blah, blah, blah. Wow. Wow. I never borked a Git project this much. It's really astonishing. I think I'm amazed at what I accomplished. So here we're going to delete. Let's try to delete the so git rm f raylib. So let's do git rm libraries / raylib. Wow. The module's there though. We're gonna delete it. Wow. CD libraries. Everything is going fine. I'm not whining at all. I'm just learning stuff, basically. So we're gonna git clone it. It's gonna take some time, and we're gonna survive. So in the meantime, what we could probably do is we could probably do like a knob.c, and then we're gonna get the code from our other project. That here, and then we're gonna do this, and then we're gonna do yeah, so it's kind of done. So we don't need that one. We do need this one. So this one we're gonna call it yeah, so we're gonna call it raylib. So let's call it like lib raylib. Maybe it's gonna be fine. Okay, and then what we do in the other project is we get the O files. Maybe I'm just gonna call it like libraries. 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 Because I think that the name has an impact or something. So, and then in this one, what we can do with you is add. Yeah, these flags are not needed in this case. We can do this. Failed compilation of submodule. So let's go in libraries. And then so we're gonna compile those, and then we need the .o files to be added to the command that we build. So like right here, right right there. Right there. In my includes, I'm probably going to need the includes of raylib. The includes of raylib. Where are my includes? Where are my includes? There we go. Sorry for the singing. Sometimes happens. I don't have the best voice, but I can handle it. So let's see it fail. So it did not fail. I like that. So it did not fail. Why do I have like 2 times GGDB3? Like, do I have 2 times GGDB3? How much time? How many times do I have it? Why do I have it twice? Probably because I'm using the config. So, yeah, now it has it once. Okay, cool. So I mean, we don't care, right? That's a raylib thing. Okay. And then what we do is we add raylib in there, right? We add raylib in there. We add raylib in there. Raylib in there. So GCC, raylib, R shapes, R text, yeah. I mean, it works. So we can do that. Now what we can do is we can go in our main. Our main here. That's the thing, right? So the core key part is actually knowing when we're going to need to destroy the VM and then recreate the VM. Now we're going to need to have like a state that we can pass or data that we can pass. Yeah. Because right now the issue is we create the environment, but we're going to need to have a way to restart the environment, which is going to be a challenge in itself, but I think I'm going to like it, actually. So, how do we do this? So we're going to start by actually not doing this like this. So while because we're going to use not window should close. Now, where is this coming? Yeah. Do I include raylib at all? So how does it know that this is a raylib thing, though? Like, okay, whatever. It just knows. Fun. So we're going to include raylib.h. So include raylib.h. Ugh. Dude, you do know what to do. Add. Yeah. Just do it. Just do it. Basically. So we call that until we're done. Now, for now, what we're going to need to do is init window. Let's do like 720 by 480. And then let's do like Q3 VM tests. And then here we would do close window, close window, like this. And then what this will do is we can do like F5. This should create a window. And then when we do escape, what is it? Like, because I know that the window should close thing. Yeah. What's the window should close? Core window. Loving it. So let's do like equals or whatever. Yeah. Yeah. So window close. And then, okay. Let's do the glfw. And what key is that? So I have a game. Oh, I think I remember. So for whatever reason, you need to do like begin draw. Is that it? Yeah, you need to call like begin. I forgot my. So begin drawing. Wow. So like doing all those things is needed for some reason. So begin drawing and then end drawing. So if you don't do both of those, I guess it doesn't work. And then we can do clear background. And then we need a color. So let's pass OX FF 0000 FF. And then we can just use like get color. Okay. So this is marvelous. So this should give us a window like that. Then we can do like that. Then it's going to shut down. It's going to shut down. Okay. So that works. Now, I think we're gonna need like an include that works both in the runtime and in the so the next step is we need to actually expose functions. Now the logging function is not as simple as I would like it to be. So we're not going to use that one. But we have rendering functions in Raylib. So I'm probably going to use those. Yeah. We are going to use those. Okay. So we're going to have a draw function. So right now we don't. Whoa. So it's going to be dark. It's going to be dark in here. Let's do draw, like, yeah. Come draw. So you don't know what come draw is, so let's do that. Now in our Gmain, we are going to have the come draw. So we are, you're whining because you're not supposed to be doing that. Drawing stuff. So now it's going to be updating and then drawing stuff, which is what we want, basically. Yeah. So updating logic, drawing stuff. Okay. Which is great. 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 So great. So now we need to start doing more complex stuff. So for whatever reason, to create new functions, we need to do this. So draw rect. Whoa. 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 Yeah. Yeah. What happens if I include Raylib? So let's have a look at the function. The function's not going to work. The function is not going to work. So let's call it like oh, well, it is going to work. Ish. Now we can remove this because this isn't true anymore. So Raylib, draw. Where do you draw the line? Draw the line. Yeah, so let's draw a rectangle. Where do you draw the line? So draw a rectangle. Now in our main, we're gonna do draw rectangle. Now mem copy. Okay. Mem set, mem copy. So you can receive pointers. Huh. I'm gonna have to fiddle with this. But for now, let's just try to implement, yeah. So like, this just means that you're receiving a 1, a 2, a 3. So the draw rectangle. So let's draw rectangle. And then a 1, a 2, a 3. A 1, 2, 3, 4. Sorry. My brain goes places. And then what we're gonna do is we're actually gonna be doing get color. This like this. Because anyways, it's always annoying. Okay. And then do we return something else? So they always return, right? So this returns. Like, sure. Let's return 0, I guess. And then our draw rectangle is going to, let's go have a look. So yeah. So we're going to use this, but what we're going to do is we are going to let's call it draw rect. And let's use like unsigned int for the color. So unsigned int. Okay. So now, so this is a function that never exists. Okay. Okay. So that's not really what we want. Let's include Raylib in the gmain, because if I can just like include Raylib, that will be like perfect. Now, this probably won't work. Yeah. Ah, that is an issue. Uh, bit by bit. So it seems it would understand what? So like if I do VMF, VM int to float. Where is that? Where is that defined? Float to int. Where is that called? And it's called nowhere. It's probably so VMA. So that's a pointer. That's a pointer. Ah, I get it. So args. Okay. Args 1. Args 2. Okay. Args 3. And args 4. And then args. Yeah, this. So args 5, right? So this should work-ish. And no, it does not. Could not find include file raylib.h. Okay. Let's copy that. And let's have a look at like what commands. Like, can it just have like, yeah, system specific args. PFAL. Okay. Let's do something like really stupid. Ha. So let's do raylib defs.h. So then what we could do is we would get, I guess, our raylib draw rectangle thing. And then do... Oh, yeah, that's it. So since it does not need to be exist. Oh, that's perfect. So it can be like just this, and then oh yeah, unsigned unsigned int. Now the thing that I won't like is, let's say, so this is the scripting code, right? So it's not the end of the world, but as soon as I want to compile that, the raylib-defs thing, yeah, that's going to be a pain. So let's draw a rectangle. Draw rectangle. So let's draw it at 100, 100, 100. I like 100 apparently. And then for the color, we're going to do OX, FF, OO, 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 and FF. So now what's going to happen is it's going to crash probably because reasons. Illegal operation. There's no new line. Kind of worrying, I think. Cool. It works. So we can draw stuff. Woo! We can draw stuff with raylib using QVM code. Okay. Okay. So, the quick thing I want to test. So if we recreate a new version, how will that work? How will it work? Okay. I think I need to limit the FPS for now, because yeah, we need to set the target FPS. So set target FPS to 60, because wow, is this using my CPU for no reason? My CPU is going less fast now. Less speed is being used. Still VS Code. VS Code, I think VS Code is going to be my bane. The bane of my existence. Like, it has no reason to be running at that. Like, OBS has reasons to run at 3%. This, no. Anyways. So, we have our little rectangle. Let's try something else. So, get color is a function that returns. So if you have a look at get color here, you received an unsigned value, and then you get a color. So I'm curious, can I do this? Because it's going to need to know, like, what is a color, right? So, like, so get color. Yeah, so you don't know what that is. But if you did, would you be fine? So raylib. La 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 la. Where's my get color? Where is my get color? Get color. Raylib. Get color. So then we need the color. So we can do that like this. And then what do you mean overloaded function get color? Is this actually going to be an issue? I don't think so. And then if we do like color, and then in our VM, how is it going to work in our VM? Because we're just going to return args. Huh. But we can do that and then do so we can do that. So 5. So we would say like you're a color pointer, I guess. Color pointer. And then we would do this. Like logically, this would be logical. And then we need to implement in the commands, no, in the syscalls. We're going to do get color. I mean, no. I mean, yes. Okay, so this would be 6, right? And therefore, what we could do in our main is we could do get color. Would that work? We shall see. Bad system call 6. Why? Oh, because I'm a dumbass. Because I'm a big dum-dum. I'm a big dum-dum. 6. And then we would do, so get color. You see, like there's some things that are going to be like annoying. So that would be arg0. So get color. So my feeling is we're going to need to keep a static of the last thing. Ooh, Ew. So void pointer color is going to be able to null. And then color is going to be this, and then you're going to turn color this. So color pointer. This probably won't work, but I just want to test things out. Segfault. What? Why do you segfault though? I mean, it's interesting. So color call. Are you just trolling me? Like, really? It's trolling me. So I'm just being a dumbass. I'm being a dum-dum. Dum-dee-dum-dum-dum. A big dum-dum. I'm being a dum-dum. Dum-dee-dum-dum-dum. This should work. Here's hoping. So no, does not work. So, color, call, args 5. Right, that makes sense. So cast it to color. Cast it to color pointer and then re-reference. Wow. Wow. This does not make sense. But what is RX5? So we can't get structs. So the best way of doing it is actually how I did it before. So we don't do it that way. We do it this way. Yeah, we do it this way. And then what happens is, you in the raylib defs we just have unsigned int. Because apparently structs are bad. Structs are bad. You get struct by the struct. I don't need this anymore. So we can draw again. So let's have a little test just for the hot reloading thing. So here's how I see it. The way that I see it. So the way that I see it is what's going to happen is in here somewhere. Haha. So if gmain.c, okay, I did not include knob. So let's include knob. La 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 la. So we're just gonna test this out. Knob needs rebuild 1. Right? Yeah, output path, input path. So if this is true, let's just do a log. Let's do a log. So, what is it called in log? No, what is it called in raylib? Because it's not print. Let's just do like the trap. Let's fall into the trap. Let's fall into the trap. So let's rebuild. Because like what we can do is we can just like create a new virtual machine. And then if that virtual machine actually worked, we use the new one. Okay. Okay. So we're going to do this too. So if the QVM file is older than, so the output path and the input path, I mean like both have their, so let's do like this. That's dash slash scripts gmain.c, and we're gonna do it's gonna be bytecode.kvm. So if the file is younger than this file, okay, so let's do that. Okay, let's rebuild. Like, maybe it should be main. So dot main dot asm in build, right? So let's do that one instead. Really? Output path time. Okay, so if I inverse so that's the, yeah, okay. So if I do that, then will it rebuild? So it's not rebuilding. And then if I go in gmain and I change that to like this, let's rebuild. Okay, so it did change. So we're testing out the reloading. So we're gonna have the hard time of like just compiling stuff. So yeah, we need to do basically all of that. Yeah, we're gonna remove this boy. We can probably remove those. Yeah. Like, we still need the command, but we don't need to render these boys. They're not important. They're not important anymore. So, let's just do that. I mean, you don't return, right? We're gonna change how it works. Bloop. Let's not do this. Let's not do this. Yeah. Okay. We don't have path sep. We do have path sep. So that should be probably dot dot. That should be dot dot. Dot 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 dot. So dot dot. Oh. So, like this, I guess. And I guess this is this. And this. Something like that. Okay, so, so knob CMD. It's going to be an underscore. CMD is equal to this. LCC flags assembler blah blah blah. So I'm gonna go get those. They are needed. That's the libraries. That's the libraries. And no, I wanted LCC and the flags. LCC and the flags. That's a nice name. Maybe I can put the defines here for now. Ooh. I'm gonna need to do like dot dot and then dot dot, I guess. And let's just do an error message. So let's do like error couldn't build file. And then let's just do that. I'm just going to say error couldn't assemble file. And then what we're going to do is we're going to do let's just do it YOLO. So we're going to do VM free. And then what we need to do, oh, we can't do that. Not yet. Huh. Because I think they might be needed. So we're just going to create a like temp image. Because what we actually want is, we're going to need temp image size. Temp image size. So then we do temp image size, and then this guy is going to be 0. So then we're going to load the image. And then we need to create. So we're going to need a temp VM also. So temp. Let's call it static. And then temp VM. So then what we can do is if is equal to 0, we're going to do this. We're going to do temp image. And we're going to use the file path. So if this is true, we're going to do memset VM. Memcopy actually. So I'm going to do memcopy this from the temp VM size of VM underscore T. So that way it gets reloaded. If not, let's just not do anything, I guess, for right now. Okay. So let's hope that it works. So then in gmain, we're going to do VM not loaded. That's an interesting one. So let's go have a look. Oh, what? Yeah, well, because I'm a dummy. That's why. If this happens, though, I want to see, like... I want to break. So then, like, all the rest just worked. So gmain. Okay, so this works. What? Oh. Okay. So if this happens, we can free. Okay. We can free VM free. We can do that. We can do both of those. Right? Yeah, we can do both of those. So then we can do that. Then we can do this. Then we can do that. And then image becomes temp image. Right? And let's do like image size becomes temp image size. Because I don't want to mix things up eventually. Wow. So I think we're going to be able to like reload stuff. Because like the main logic of stuff won't be needed. Like the state is going to be kept by our application. It's not going to be kept by something else. So it should be fine. Okay, so we have our rectangle here. So we're going to change it. I'm just going to make sure that I don't have like any breakpoints, because that would be anticlimactic. So G main. So then we're going to do 0, 0, 0, 0. And let's add an error. So this just reloaded everything. So we can change that to like anything that we want, which is kind of marvelous in this context. And then this can be like 10, 10, and like this can be 200 by 200. Yeah, okay. I really like this system. Like, this is instant. Like, I don't need to build anything. It just builds itself. I'm kind of curious, like, let's say I would make a more complex game, right? Because like right now, this is really simple. But what I would actually do is I would build my engine around this logic. So you would have like all the updates of all the entities that would be called here. All the draws of all the entities would be called here. So the only situation where you would have to actually reload is when you want to reload assets. But we could add a call like to load assets. Yeah. Anyways, like that, there would be a way that we could do stuff. I think that the next step, like for now, I'm kind of happy with what we have. So like what we have is just a system that works. Oh, that's too far. Yeah. So we just have a system that works, that like as soon as I change the file, completely updates it. So let's say like let's add an error. Let's put a float in here. What's gonna happen? It's still gonna work. Let's put a .5. Okay. So it's still gonna work, but it's not gonna be a compile error. Wait. I did not test. Like maybe it didn't work, and there was an error. Huh. Let's have a look. That's the interesting part. So like else error encountered, I guess. So like fprintf. So like error when loading file, because I think if I have a compile error, it doesn't do like specific things. Maybe I could have put like this here and this here and then this here. Whoa, yeah. Let's stop it for now. So let's start it again. Okay, so the Q3VM test. I would like it if, like, as an application, my editor could actually just embed the game directly, because right now it's really annoying. Yeah, right now it's really annoying because I have to like reposition everything all the time, and then it gets it doesn't remember its position, stuff like that. Okay, so the thing that I need to do, I need to go in the gmain and then like just do an error. So .f. So it doesn't seem like, so like the compilation worked, but the compilation shouldn't work. Let's, yeah, we're printing logic basically all the time. So I can just not do that. Loading VM file. Okay. And then it did not call none of those. So at least it kind of understands. Yeah, it understands the pathing. The thing that I love about this is I could modify the syscalls, and since the build considers the syscalls, I could do it in real time. So that's even better than C flat, because C flat you always needed to like recompile all the time every time you change something. I mean, we're probably going to need to still, because it's not going to be implemented in the system calls here. Yeah. That's sad. The sad part. Anyways, like we didn't encounter like any errors. Let's put an error in there and let's see like print. Yeah, couldn't build file. And then it's just, yeah, it's just gonna work. So we're gonna in the future. Oh, that I do like. So if I fix the error and I reload the file, then it's fine. Ooh, me likey. Yeah, I like that. I really do. And like even right now, even if I haven't, I could completely keep them as separate executables. I wouldn't need to actually make executables like out of them, like make a distinct executable. So I can just use them as they are right now. I like that. Ooh, I like that. Because I'm lazy. And that makes it so that I can be as lazy as I want, basically. So we could put like lcc.com, because it's going to be a .com file eventually, directly in the deployment folder. So then we could just like call directly like deployment or whatever. Or we could have like a binary folder for those. And they could work on either Linux or Windows. Yeah. I'm quite glad with this experiment. It's an abomination, kinda. But it's a really interesting abomination. I like the iteration times that it has. It has the same iteration time as C flat. Though the issue that we might have is on like having to implement things. So it's still good. It's fun. So thank you for watching, for everyone that was watching right now or not. And see you next time when we're actually going to put a game on screen, because right now we couldn't, because we were just trying a test. But the test is successful. So yeah, see you, Maven. Mickey Maven. See you next time. Okay, bye-bye.